Welcome to this video, where we'll be explaining how generative AI works. My name is Marcel and I am an expert from the Center for Deep Tech Innovation. The video is targeted towards innovators, business executives, entrepreneurs, managers and disruptors and is part of a long-term video series. We will learn where the current wave of AI application comes from historically and what are the key concepts. If you like this video, please follow us at the Center for Deep Tech Innovation. We have a newsletter and we do a bunch of webinars for you. So let's dive in. Today we are all buzzed by the exciting new innovations that come from ChatGPT, Midjourney and co. These tools are all examples for generative AI. Yet there are other types of AI. I grouped them here into 5 different groups. Group 1 is focused on optimization, simulations, modeling and predictions. This group of AI techniques was initially proposed in the 1950s and has since undergone 2 major breakthroughs, one in the 1980s and another in the 2010s. These techniques are used to model problems and find the best solution for them, or to make forecasts about future events. One example of optimization techniques in AI is the use of algorithms to optimize supply chains. These algorithms can be used to determine the most efficient routes for shipping goods or to identify the optimal times to restock inventory. By optimizing supply chains in this way, businesses can save money and operate more efficiently. Another example of AI simulations is the use of computer models to simulate weather patterns. These simulations use complex algorithms to predict how weather patterns will develop over time and can be used to make forecasts about future weather conditions. The information can be used by farmers to plan their crops or by emergency responders to prepare for natural disasters, or by you to go to vacation. AI modeling techniques can be used in a variety of different fields, including finance, medicine and engineering. For example, AI models can be used to predict stock prices, diagnose medical conditions, or optimize manufacturing processes. AI prediction techniques are used to make forecasts about future events. This can include predicting which customers are most likely to make a purchase or forecasting which products are likely to sell well in the coming months. Group 2 is focused on clustering. Clustering is the process of grouping data points together based on certain criteria. The first examples of this group of AI techniques was initially proposed in the 1960s and has since undergone 2 major breakthroughs, one in the 1990s and another in the 2010s. One example of clustering techniques in AI is the use of customer segmentation in marketing. By clustering customers based on their demographic information, buying habits and other factors, businesses can tailor their marketing efforts to specific groups of customers. For example, a clothing retailer might cluster customers into groups based on their age, gender and clothing preferences, and then create targeted marketing campaigns for each group. Clustering techniques can also be used in fraud detection, where AI algorithms can group together transactions that are suspicious or fraudulent based on certain patterns or characteristics. Credit card fraud detection is one of the key examples for that. The next group is focused on recommender systems. Those AI algorithms recommend items to users based on their previous history or the history of other users with similar preferences. The first techniques of this group were initially proposed in the 1990s and have since undergone a major breakthrough in the 2000s. One example of a recommender system is the product recommendations on Amazon. When you purchase an item on Amazon, the website will recommend similar items that other customers with similar purchase histories have also bought. This can help customers discover new products and make more informed purchase decisions. Another example of a recommender system is the playlist recommendation on music streaming platforms like Spotify. These platforms use AI algorithms to recommend playlists and songs based on the user's listening history and the listening histories of other users with similar preferences. This can help users discover new music and create personalized playlists. Group 4 is focused on anomaly detection, which involves finding anomalies and unusual patterns in datasets. The first instance of AI anomaly detection techniques was initially proposed in the 2000s and has since undergone a major breakthrough in the 2010s. One example of anomaly detection techniques is in predictive maintenance for manufacturing equipment. By analyzing data from sensors or machines, AI algorithms can detect unusual patterns or anomalies in the data that may indicate a problem with the machine. This can help manufacturing companies identify and fix problems before they lead to equipment failure and production downtime. Group 5 is finally a group we call Generative AI, and it is focused on creating text, images, videos, and voice from learned features from existing datasets. Let's zoom into generative AI and look deeper. The first core breakthrough in the field of generative AI came in 2014, when a group of researchers from the University of Toronto developed a neural network that could generate new images using deep neural networks, and it became quickly the basis for many other generative AI algorithms. After the breakthrough with deep neural networks in 2014, the researchers continued to push the boundaries of generative AI. In 2015, a team of researchers from the University of Montreal developed an algorithm that could generate realistic-sounding music. Then, in 2016, a research group from Google introduced WaveNext, an algorithm that could generate natural-sounding speech. This was a significant breakthrough, as it allowed the creation of more human-like voice assistants and other applications. In 2017, the first so-called transformer model was introduced in a paper called Attention is All You Need. This model used self-attention to process input sequences and achieve state-of-the-art results in language translation tasks. This mechanism also allows the model to focus on the most relevant parts of the input sequence when generating an output, resulting in a more accurate and fluid natural language generation. Based on transformer models, a new type of generative AI called style transfer was created. Style transfer algorithms could take the style of one image and apply it to another, creating unique and artistic visuals. Let's you, for example, create images based on inputs in the style of Van Gogh. In 2018, the same year that GPT-1 was released, NVIDIA also introduced an algorithm called GANs, Generative Adversarial Networks. GANs work by generating new content and then using feedback from a mechanism called a discriminator to improve the quality of the generated content. GANs have been used to create photorealistic images as well as to create new video game characters and even faces that don't really exist. More recently, in 2020, OpenAI released GPT-3, which is one of the most advanced language models to date. GPT-3 can generate text that is difficult to distinguish from text written by humans, and it has many potential applications in the field of marketing, in customer service, or in content creation. This year we have seen the newest iteration of the generative pre-trained transformers, GPT, with GPT-3 and 4. There are many other models that base on that, like ChatGPT. Here on the right side you can see a tree representing how all these models evolved and how they build on top of each other. So now we know where generative AI comes from and why now is the time it really got the traction it has. In the next video of this series, we will go into the core concepts behind generative AI, maths, tokens, and predictions. Don't worry, you don't have to be an expert in math. We'll keep it quite high level and understand the essence of it. If you like this video, please give it a thumbs up and subscribe to the channel. Follow our LinkedIn page and check Eventbrite for the newest events. Subscribe to our newsletter to stay up to date with the latest in AI. Until then, see you next time.